Hello everyone, in this video we are going to talk about the celebrity problem and we'll see how we can use different approaches to solve this problem. So let's talk about the celebrity problem. So in the given problem we are given n persons having id 0, 1, 2 till n minus 1. So there will be n persons altogether and we were also given a 2D matrix. Now this 2D matrix basically tells if a person knows one person or not. What I mean by this, let's take an example of a 2D matrix of size 3 cross 3. So I've made the indexes here. I'm going to show what is going to happen here. So if a person I knows a person j, in that case the value of the matrix at the index ij will going to be 1. If I does not knows j, in that case the value at the matrix ij is going to be 0. So let's say in this example, let's take an example from the given matrix 0 1 0 0 0 and 0 1 0. Now in this example you can see that here at the index 0 1 the value is 1. That means the person 0 knows 1, and for this entire row the value is 0, and for this entire row the value is 0 1 0. That means the person 2 knows person 1. Now in the celebrity problem, person is called celebrity if each one of the person except the celebrity, let's say if the person 2 is celebrity, then each of the other person other than the celebrity knows this person every one of them knows this person who is the celebrity, but this celebrity should not know anybody, right? So what I mean by this, so for this example, if we say if we have to check whether the person 2 is celebrity or not, so we can see that the person 2 knows person 1. That means in this example the person 2 is not a celebrity. If we talk about the person 1, the person 1 does not know anyone, so we are sure that whenever a person x is a celebrity, then the matrix at x and remaining all other elements should be, so for the entire row x the value should be 0 because the person should not know any other person, right? But every other person should know this person. So the person 0 knows about 1, the person 2 knows 1. So in the given example the person 1 is a celebrity because this celebrity does not know anyone, but every other person knows about the celebrity. So let's see how we can solve this problem. So first of all, let's talk about the most basic approach, which is the brute force approach. So what we are going to do, basically we have n persons from 0 to n minus 1. So for each of the person from the index 0 from the person 0 till n minus 1, I'm going to use a for loop and I'm going to iterate from 0 to n minus 1, and for each of these persons I'm basically going to check if the person I is known by any other person or not. If the person I is known by all other n minus 1 persons and this person I does not know any other person, that in that case the person I is the celebrity. Let's take an example and try to understand it. So here initially the value of I will be 0, right? These are the indices for rows and these are the indices for column. So for the index 0, I'm going to check if the person like I knows any other person or not. If the person I knows any other person, then that case that I person cannot be a celebrity. So in this example, like for the row 0, the person 0 knows the person 1, in that case I cannot be the celebrity, so I will be incremented to 1. Now this entire row should be 0. For the entire ith row should be 0, because that person I should not know any other person, right? So in this example we can see that the person 1 does not know anyone, but we are not going to stop here. We also need to check whether the person I is known by all other persons. And how we are going to do this? Basically take the ith value as the column, right? And then check in this same column, in the ith column, if the count of ones is equal to n minus 1, right? In that case the ith person is celebrity. So let's talk about the time complexity of this approach. So basically we are initially we are using a for loop from 0 to n minus 1. So there will be n total n iterations, right? And for every iteration I'm also going to check whether the ith column has n minus 1 number of ones or not, right? So what does this mean? That for the every iteration I'm also going to check the row as well as the column, so it will be 2n. So if I talk about the time complexity, this is going to be O of n square, right? If I talk about the space complexity, then it will be O of 1, because we are not creating any extra data structure here, right? We are not storing any other value. Basically we are just storing everything in a counter variable. So since we are not using any extra space which is related to the value n, so therefore the space complexity is going to be O of n, O of 1. So let's see how we can apply this approach. First of all, I'm going to copy the template code. I'm going to store the value of n as the size of the matrix, because this is a square matrix, and let's name this as I. And as I've said earlier, we are going to iterate till n minus 1, and for each of the values of I, I'm going to check in the entire row as well as the particular ith column to verify whether the ith person is celebrity or not, right? So what I'm going to do, I'm going to create a counter variable, and first of all I'm going to check in the basically the ith row whether all values are 0 or not. So I'm going to iterate from 0 till n minus 1, and if any of the values, that is matrix of ij, is equal to 1, in this case the ith person is not a celebrity, not celebrity. So what we are going to do, we are simply going to break through the loop, right? So if we have not broken through the loop, then in that case basically I'm also going to use a bool variable. Initially its value will be true, and if this is the case, I'm going to change the value of flag to false, which means the ith person cannot be celebrity. So I before checking the ith column, I just need to check if flag is true or not. If flag is false, then there is no reason to check the entire ith column to verify whether the ith person is celebrity or not, right? So again what I'm going to do, I'm again going to run a loop from 0 to till n minus 1, and here I'm also going to check the increment the counter variable depending upon the ith person is known by other persons or not, right? So basically the column will be I, right? If I show from this example, if I have to check the ith for the ith person, in that case first of all I have checked all the values in the ith row, right? And then I have also checked from the ith column. So the value of the indexes representing the column will be equal to I. Later I just need to check if counter equal to n minus 1, then that case we just need to return the ith person. And if this is not the case, for if none of the person is a celebrity, then that case I just need to return minus 1. So let's run this code. Let's submit the code. So here you can see that the code has been successfully submitted, and the space complexity was O of 1 and time complexity of O of n square. So let's see how we can optimize this code. In order to optimize this code, we can use the elimination approach. We do not need to check for every ith person for the entire row as well as the column, right? Instead of doing that, we are going to use a different approach. So what I'm going to do here, I'm basically going to create a stack, and in that stack, first of all, what I'm going to do, I'm going to push the first person, that is the 0th person, right? And another person, that is 1. So what I'm going to check, I'm basically going to check, first of all I will pop out the first two elements, that is 0 and 1, and I'm going to check if this first person, right, knows the second person or not. If the first person knows the second person, that is 0 knows the person 1, then that case 0 cannot be a celebrity. So what I'm going to do, I'm not going to insert 0 back, I'm going to insert the second element, that is 2 and 1, right? So again what I'm going to do, I'm going to check for 2 and 1. If the person 2 knows 1, if the person 2 knows 1, then that case the person 2 cannot be a celebrity. So again I'm going to push the next element. So in this way I will just keep on pushing next elements, I will keep on incrementing the persons, and I will keep on checking if they can be if I give a general example, if A knows B, then that case I'm not going to insert the element A back to this tag because A cannot be a celebrity, right? So I'm just going to insert the next person after B. Let's say it was C. So in the stack B and C will be inserted, right? Now again for C it will be checked if the person C knows B or not. If the person C knows B, then that case B can be a celebrity but C cannot be a celebrity, right? So I'm going to insert the next element into the stack, right? So in this way we will keep on doing this until there is only one element in the stack. But let's say after all the insertion and deletion there is only one element X which is remaining in the stack, but we cannot be sure that the person X is necessarily a celebrity. The reason is that if we keep on doing the elimination, then there will be a point of time when the X element, although let's take an example. So out of A and B, we had eliminated A because A knew B, right? And out of B and C, C knew about B, so we had eliminated C. Now out of B and D, B also knew about D also knew about B, so I had eliminated the element D here, so only B is remaining. But there is a possibility, since I'm not checking whether B knows C or not, so there is a possibility, I'm just checking only if C knows B. I'm not checking if the person B knows C or not, right? Like I'm not checking in two directional ways, so there is a possibility that the person B might not be a celebrity. So at the last I will be remaining with a single element only, and I need to check explicitly whether the person which is remaining in the stack is indeed a celebrity or not. And how I'm going to do here, it is very simple. First of just go through the entire xth column, right, and just figure out the number of person who knows this person x. If this value is equal to n minus 1, in that case x is the celebrity. So let's code this problem. Now this time I am going to create a checker function to verify the xth element is indeed a celebrity or not. Let's name it as celebrity, and let's take the reference of the matrix. Let's create a counter variable, and all I have to do here is just check from 0 till n minus 1. Here the row will be I, the column will be equal to celebrity, and I just need to check if the counter is equal to n minus 1 or not. So this function will be used to verify whether the given celebrity is indeed a celebrity or not, right? So now I'm going to check, I'm going to create another function, a recursive function for finding the potential celebrity. Let's name it as find celebrity. So I've created two variables. One will is the potential celebrity, and the other person will be used to like keep on incrementing it so that we can search for other like we can search for more potential like values which can be celebrities. So here I will also give a reference to the matrix. Let's write the base case here. Now what will be the base case? In this example, in this recursive function, basically the other, if the value of other is equal to n, basically our search space is from 0 to n minus 1, so the value of other will cannot exceed more than n minus 1. So if that is the case, that other is equal to n, then in that case we are simply going to return the celebrity. So if just check if other equal to matrix dot size, which is the value n. To remove confusion, I will just initialize the value of n as matrix dot size. If this is the case, then I'm just going to return the celebrity. Here it is celeb, right? Otherwise I'm just going to check if the given celebrity knows the person other or not. If the given celebrity knows the person other, in that case that celebrity cannot be the celebrity, the celeb cannot be the celebrity, right? So I just have to check if we just need to check if the celebrity knows other or not. If that is the case, then that case the celebrity cannot be the variable celeb cannot be the celebrity. Then I am going to pass the celebrity as another person, which will be the other person. We will consider the other person as the new celebrity, and the other value will be equal to other plus 1, right? And I have just passed the matrix here. If that is not the case, then what I'll do, I will simply call the recursive function find celebrity once again, and celeb will remain as it is because the celeb does not know about other. So the other person, if celeb does not know about other, then in that case I will increment the other variable to find more persons, right? So now I'm just going to find the potential celebrity using the find celebrity function. Just pass the initial celeb value as 0, other as 1, and pass the matrix, right? And just check. Once I'm done with this, I just need to check verify that the value I have received from the find celebrity function is indeed a celebrity or not, and I can do it using the check function. Here I am supposed to pass one value as celebrity and the other as the matrix. If so, what I'll do here, I will simply return. First of all, I will just check key if the person I have supposed was celebrity. In that case, I will simply return the value of celebrity. Otherwise, I will set it on -1 because no celebrity exists for the particular test case. Let's compile and run the code. Let's submit it. It says there is a wrong answer. For this particular test case. Let's check it. So here initially let's debug this code for this particular test case. So initially I have taken the value as celeb as 0, other as 1. Here the value 0, zero knows about 1, so 0 cannot be the celebrity, so 2 will be inserted. So let's first of all now let's verify whether the person 1 is celebrity or not. So in the first column I can see that the value of counter variable will be equal to 2, which is correct. I think I was also supposed to check for the ith column as well. I have missed that part. I was also supposed to check for the particular row as well to verify whether the person celebrity knows any other person or not. So I just need to make few changes in the check function or not. I will create another counter. Instead of that, I can simply just check if the matrix of celebrity I is 1. In that case, I am simply going to return false. because here I was supposed to check for both the column as well as the row. So this was the mistake in the code. Let's run it once again specifically for this test case. So you can see that this code has also passed the all the test cases. So let's discuss about the time complexity. So here you can see that for any value of celebrity and other, I'm simply just inserting new value of other, right? I'm just incrementing the value of other and changing the potential celebrity. So at max, the number of elements in the stack will be equal to how many? Till n, right? So the space complexity will be O of n and time complexity will also be O of n. So let's try to build another approach to for this problem where I'm going to optimize the space complexity here as well. I'm not going to use a stack. I'm going to use two pointer approach. So let's say for n equal to 6, my initial value, that is the celeb, I will say the potential celeb is 0 and the other person will be n minus 1, right? And I'm now going to check if the celebrity knows the other person or not. If celebrity knows the other person, then in that case I'm going to increment the celebrity, because the current value of celebrity cannot be the celebrity, right? Celeb cannot be the celebrity, so I'm just going to increment this pointer if the celebrity knows other, right? And if the celebrity does not know other, then in that case the value celeb can indeed be a celebrity. So since I've already checked for the other person, I will decrement it in order to check for other variables like other persons. So let's write a pseudocode here. If the matrix of celebrity other, let's represent it by the variable O, if this value is 1, then that case I'm going to do what? I'm going to increment the celebrity, because the current value cannot be a celebrity, right? Otherwise the current value celeb can indeed be a celebrity. It has potential to become a celebrity because the celebrity does not know the other person. So I'm just going to decrement the other variable. So this will be the change in the code. Here of instead of calling the same find celebrity function recursively, what I'm going to do, I'm going to have two pointer technique here. Celeb will be initialized to 0 and the other variable will be initialized to n minus 1, and this loop will continue until celebrity is less than other. Less than equal to other, right? And then what I'm going to do, I'm just going to check if matrix of celebrity other is 1 or not, which means if the celebrity knows other, if the variable celeb knows other, in that case the celeb cannot be a celebrity, so just increment it. Otherwise the celeb does not know other, in that case just decrement the other variable, right? And here only I'm just going to check if the so the potential celebrity will be stored in the value celeb, right? So just check if use the like pass celeb as the potential celebrity and pass the matrix. If this check function returns true, then that case celeb will be indeed the celebrity. So just return the celebrity. Otherwise, simply return -1. Let's test this approach as well. So here you can see that there is a compilation error. Int celebrity equal to find celebrity. Here we need to make some changes. Just simply return find celebrity, value returned by the find celebrity function, and do not pass any initial values because there is only one argument. Let's submit this code. So here you can see that this code has also passed all the test cases. So let's talk about the space and time complexity of this approach. So since I'm not creating any extra data structure here, I'm not using any other stack. So due to this, I'm only going to basically I'm just incrementing the celebrity variable or the other variable or decrementing the other variable, right? So in the worst case, what will happen that the celeb variable can reach till the value n-1 or the other variable can reach to the value 0. So in the worst case, what will happen, not in the worst case, in every case what will happen that there will be equal to n iterations, right? So the time complexity will be, actually in every case it will be O of n only because I'm just keep on incrementing or decrementing the celeb and other variables till they collide at some point. So that is why the time complexity will be O of n only, but the space complexity will be O of 1, right? So that's all for the video. See you next time.